So this is the third session on physical chemistry. We have covered some chapters in part 1 and 2. If you have missed those videos, please go over to your YouTube channel and they are there. So these are important chapters. Solid state, right? The questions come. Electrochemistry and chemical kinetics, these are particularly very important chapters, right? And you can see they have shown it quite clearly. This is the body center, right? This question is selected because coordination number is something which have been asked very frequently and you should know, right? So root 3a is equal to 4, I'll take capital R. Look at this question. The resistance of 0.2 molar solution of an electrolyte is 50 ohm. Opposite of low is high, opposite of oxidation is reduction, opposite of anode is cathode, opposite of negative is positive. That means cathode will be positive. At cathode, reduction happens and that should have high potential. Now let us discuss some important questions of chemical kinetics. This is one type which is asked very frequently in JEE based on the order of reaction. So the rate of reaction would be K, the concentration of A and the concentration of C. Then the degree of dissociation of a first order reaction is 1 minus e raised to the power minus kT. It is also asked directly. Let me tell you one thing, I have picked up these problems very carefully. I have picked up those set of selected problems which cover the most important concepts, the most commonly asked concepts in the examination, right? Hello students, welcome to this video. Welcome to this Power Up series where we discuss the chapters of chemistry on a fast track with some important problems, alright? So this is the third session on physical chemistry. We have covered some chapters in part 1 and 2. If you have missed those videos, please go over to your YouTube channel and they are there. Please watch them, solve the solutions, and if you have any difficulty, then watch the solution as well. Alright. Today's physical chemistry part 3rd, and the chapters that we shall be covering in today's video, they are solid state, electrochemistry, and chemical kinetics. So these 3 chapters were remaining, right, from 1 and 2 part videos. So these will be covering today. So these are important chapters, solid state, right, the questions come. Electrochemistry and chemical kinetics, these are particularly very important chapters, right? Definitely there is one question from electrochemistry and one question from chemical kinetics in JEE. Alright, so as usual, I will take up some important problems from each of these chapters. I will explain you the background concept, right? And let me tell you one thing, I have picked up these problems very carefully. I have picked up those set of selected problems which cover the most important concepts, the most commonly asked concepts in the examination, right? So let's start with the first question from solid state. Again, if you want to solve this question, you can pause the video, right? Work out question yourself and check the answer here. A compound MpXQ has cubic close packing structure, right? Arrangement of X. Its unit cell structure is shown below. What is the empirical formula of the compound? You can see that this is a cubic unit cell. There are 2 types of particles, capital M and capital X, and they occupy corners, edge centers, face centers, and body center. Okay, so this is one of the basic things that you should remember in solid state. What are the contributions of particles present at different locations in a unit cell? Because cubic unit cell is the most common one, so let us talk about this one only. So this is a corner particle, right? What is the contribution of a corner particle? 1 upon 8, right? Because it is shared by 4 unit cell in its layer and 4 unit cell on the bottom or top layer depending upon the particle you're considering. So the contribution of corner particle is 1 by 8, okay? Then contribution of face centered particle, it is 1 by 2. Why? Because it is shared with 2 unit cells like this. So it is a part of this unit cell only, right? So the contribution of corner particle is 1 by 8. The contribution of face centered particle is 1 by 2, okay? Then the contribution of edge centered particle, that will be 1 by 4. Why? Because it will be shared by this unit cell, 1 unit cell on top of this and another unit cell on top of this, all right? And last, the body center particle as in this one, right? The one that occupies the center of the cube. So you can see that it is completely inside the unit cell. It will not be shared All right, so let me just write it for you here. Corner particle, 1/8 of the particle belongs to a given unit cell. Edge center, 1/4 belongs to a particular unit cell. Then face center, 1/2 portion of the particle belongs to a particular unit cell, and body center simply entirely. Body center simply entirely. All right. So these are the contribution. Now this is just the information that we need to solve this question. Okay. Okay. Let us calculate the formula here. How do you calculate the formula? Just calculate the number of particles of M and number of particles of X. So M is represented by the square. So 1, 2, 3 and 4, right? So you can see that 4 of the edge centers are occupied by M, right? It occupies 4 edge centers. 4 edge centers are occupied by M, and the contribution of each M edge center particle is 1/4, that we have seen just, right? So 1, 2, 3, 4. So there are 4 particles on the edge centers. So actual effective number of atom is 4 into 1/4. And you can see they have shown it quite clearly. This is the body center, right? So this is the body center. So this will entirely belong to this unit cell only. Let us come to X. X is represented by a circle. It occupies all the corners. You can see here, right? Now in a cubic unit cell, there are 8 corners. So 8 into 1/8, that will be the effective number of atoms coming out of the corner particles, right? Then we have face centered particle, right? This is a face centered particle. 1, 2, then 3, and then 4, and then 5, and then 6. All right. So 1, 2, 3, 4, 5, 6. So 6 into half, right? 6 into half. So there are 6 face centered position, and each face centered particle contributes half to a particular unit cell. So you can see that this is 1 plus 1, 2, and this is 1 plus 3, 4. So 2:4 is the actual molar ratio. They have asked the empirical formula, which will be 1:2. So the correct answer is mx2, right? mx2. So that is how you calculate the effective number of particles in a unit cell depending upon the positions they occupy. All right. So please practice these types of questions. One of the very commonly asked questions from solid state in JEE. This is another very commonly asked question, type of question. You can see, right, this question is based upon the relation between the edge length and the radius of particle in different type of unit cells, and it is also based on the density of a unit cell, right? Two very important concepts I have picked up in this question, right? So first let us see the background concept, then we will come back to this question. Density of a unit cell, first thing you should remember, is same as the density of the solid, right? Because every crystalline solid, we imagine it is made up of these unit cells. So density of unit cell is equal to density of the solid. Now density of the unit cell is obviously mass divided by volume. Mass divided by volume, right? Mass of the unit cell is number of particles per unit cell multiplied by the mass of each particle, right? Number of particles, which we call Z, that is rank of a unit cell, multiplied by small m, mass of each particle, divided by volume. Let us say A cube. If we are taking a cubic unit cell, then the volume of the unit cell will be A cube. Okay. Now I can do one thing. I can multiply and divide by Na. This becomes the molar mass. Mass of one particle multiplied by Avogadro number, right? So please remember, density of the unit cell is simply Z into m divided by A cube Na. Z is the number of particles or formula units per unit cell. M is the molar mass, A is the edge length, N is the Avogadro number. Now I will also tell you one variation of this formula which will help you solve questions faster. So you remember, if you have practiced questions of solid state, sometimes they say there is like 100 or 200 gram substance, okay, and then find out the number of unit cells or number of particles of the density. In such questions, what do you have to do? That instead of molar mass, you can take the given mass, okay, right? That is Z, and the mass can be taken as W, right? W is the given mass, 100 gram, 200 gram, whatever. A edge length will remain same. Instead of Avogadro number, you can write just the number of particles which are present in the sample, right? For example, if I tell you there is a substance, it has density D, okay, the rank is 2, let's say, body centered cubic unit cell, A is the edge length given, mass is, let's say, 256 gram, then what are the number of particles? So you can apply this formula directly and calculate the answer, right? There have been such questions in the previous years of JEE. Now this is one thing that you need to remember. Another thing, for a simple cubic unit cell, the edge length is equal to twice the radius of the particle, right? Simple but very useful relation. Lot of questions are based upon them, sometimes directly. In a BCC unit cell, BCC is body centered cubic unit cell, right? What happens here? The body diagonal, which is root 3a, it is equal to 4r. This is the relation, all right? And finally, in an FCC unit cell, what happens? The phase diagonal, right? The phase diagonal of the unit cell, which is root 2a, it is equal to 4r, right? Root 2a is equal to 4r. So these are some very important formulas from solid state, and we will be using this formula and one of these formula to solve the previous question, this one, right? Okay, now you can pause the video, solve the question yourself, else you can watch the solution here. The edge length of the metal having molecular weight 75, so that is capital M, is 5 angstrom. This is A, which crystallizes in cubic lattice. Which cubic lattice? We have no idea. If the density is 2 gram per cc, so this is density, then find the radius of the metal atom. Now, do you guys realize one thing? Without knowing which is the type of cubic unit cell, I cannot calculate the radius, right? Because radius is related differently with the edge length in different unit cells. So I need to know what is the type of unit cell. How can I know that? Simply by the value of Z. If Z is 1, it is a primitive unit cell. Rank, number of particles per unit cell. If it is 2, BCC. If it is 4, FCC, like that. So let us apply this formula. So D is equal to Z M A cube Na. Okay. Let's quickly substitute these values. Density is 2 gram per cc. Z we have to find out. Molar mass is 75. Edge length is 5 into, this is a point where you have to be careful because density in centimeter and angstrom is 10 raised to the power minus 8 centimeter. Okay. Keep the unit same. So 5 into 10 to minus 8 centimeter and cube multiplied by Avogadro number, which is given to be 6 into 10 raised to the power 23. All right. From here, I will calculate Z. So that will be 2 multiplied by 5 cube, which is 125, into 10 raised to the power minus 24, into 6 into 10 raised to the power 23, divided by 75. All right. So this is 5, and I'll cancel it by 25. Okay. So what this will be? So Z is 2, right? That calculation we have done. You see, Z is coming out to be 2. If Z is coming out to be 2, that means it is a BCC unit cell, right? Because in BCC unit cell, the number of particles per unit cell is 2. So root 3a is equal to 4r we will use, right? So root 3a is equal to 4r I will use. The radius of the metal atom r will be root 3, I can take 1.73, right? Divided by 4 and then multiplied by 5. Okay, right? So you can cancel, this will be 1.25. The answer has to be in picometer. So when you convert angstrom to picometer, you multiply by 100 because picometer is smaller than angstrom by the order of magnitude of 2, right? So I'll multiply it by 100. So answer would be 173 multiplied by 1.25 picometer. That will be your answer. Do this calculation. I think it will come out to be 216, right? So that is how you solve these type of questions. Moving to the next one, another very common type of question asked in JEE. Element B forms CCP structure. A occupies half of the octahedral voids, while oxygen atoms occupy all the tetrahedral voids. What is the structure of this bimetallic oxide? So very simple, nothing much. You just have to calculate how many particles of B are present per unit cell, how many particles of A are present per unit cell, and how many oxygen atoms are present per unit cell. Okay. Now, if you have any conceptual gap, let us fill it. So, the most common voids are tetrahedral voids and octahedral voids, right? Tetrahedral voids and octahedral voids, right? Tetrahedral voids are twice the number of particles. As in FCC unit cell, there are 4 particles per unit cell. So, per unit cell, there will be 8 tetrahedral voids. Octahedral voids are same as the number of particles. In FCC unit cell, there will be 4 octahedral voids because there are 4 particles per unit cell. Then you can also talk about hexagonal unit cell, HCP structure. In hexagonal unit cell, there are 6 particles. So, tetrahedral voids will be 2 multiplied by 6 and octahedral void will be just 6. Okay, right? Now, let us solve this question. They have written the option as A, B and O, so I'll also write in the same manner. Okay, C, we will do it in a very short manner. Element B forms CCP structure. So, please remember CCP is FCC, right? Cubic closed packed or face centered cubic, you can call it whatever. So, element B forms CCP structure, that means there are 4 B particles, right? So, there are 4 B particles per unit cell, okay? Then A occupies half of the octahedral void. Now, tell me one thing guys, if it is a CCP structure, how many octahedral voids will be present per unit cell, right? So, you can see octahedral voids are same as the number of particles of the unit cell. So, if the unit cell contains 4 particles, the one which forms lattice, so A octahedral void will be 4. But, however, A are not occupying all the octahedral voids. They are only occupying half of the octahedral void. So, this I'll multiply by half, right? I hope this is clear. Okay. Then oxygen atoms occupy all the tetrahedral voids. Remember, tetrahedral voids, they are twice. So, if the structure is CCP, there are 4 particles per unit cell. So, tetrahedral voids will be double of that. Tetrahedral voids will be double of that. Is that clear? So, this is 2 is to 4 is to 8 or 1 is to 2 is to 4. Right? The ratio of A, B and O is 1 is to 2 is to 4. That is A, B 2 and O 4. That is the correct answer. All such questions are solved in exactly the same manner. Figure out what is the lattice, CCP or FCC, then 4. Okay. Then if it is hexagonal, then 6. Then one of the atoms will occupy tetrahedral voids, C. Tetrahedral voids will be double. What portion are occupied? Then another will be occupying octahedral voids. Then you calculate the number of particles, right? Moving to the next question. This question also asked, right? And I'll tell you a shortcut about it. Experimentally, it was found that a metal oxide has a formula 0.980, right? Or you can write this formula as, we don't write that way, but it's the same thing, right? M98 and oxygen 100. Now, metal is present in 2 oxidation states, +2 and +3. It is present in 2 oxidation states, +2 and +3. The question is the fraction. By the way, they are asking percentage, not the fraction, right? Percentage of the metal which exists as M3+ would be. So, I'll tell you a shortcut about these questions, right? You can look at this formula and you will realize that there are 2 metal atoms missing, right? Very easy, right? For 100 oxygen atoms, typically there should have been 100 metal atoms, but 98 metal atoms are present. So, 2 metal atoms are missing, right? Now, if you know the background concept, the loss of this metal is made up by the presence of some cations of higher valence, right? In this case, 3+. So, please remember, whatever is the number of missing metal atoms, the twice of that will be the number of the cation of the higher valence. I'm repeating myself. Here the metal is 98, so there are 2 metal missing. Now the higher valence cation, that is M3 plus, that will be just the double of it, that is 4. That will be just the double of it, that is 4. Now the divalent cation, which is the original cation, right, because it is supposed to contain 2 plus, will be the remaining one, right, that is the total is 98. Trivalent is 4, so divalent will be 94. Is that clear? Okay. Now you have to calculate percentage of metal which exists as M3 plus. Now it is very easy. Percentage of metal which exists as M3 plus will be the number 4 divided by total number, which is 98 into 100. Right? 4 divided by 98 into 100. So now you can solve this and you will find out that this is 400 by 98. That is a little above than 4, right? Little above 4. So the correct answer will be 4.08%. This question is selected because coordination number is something which have been asked very frequently and you should know, right? Coordination number is basically the number of nearest particles, right? That means if you take one particle as a reference, then what are the particles that are touching it exactly, right? That is called the first coordination number. Now please remember that coordination number is different for different lattices. For example, if you consider simple cubic lattice, that is primitive unit cell, right? That is primitive unit cell. So the coordination number, first coordination number, that is 6, right? In simple cubic lattice, the first coordination number is 6. In body centered cubic lattice, coordination number is 8. Coordination number is 8, right? And in FCC or CCP and HCP lattices, in both these lattices, FCC or CCP and HCP lattices, coordination number is 12. So this is something you have to remember, right? Okay. Additionally, you should know that in case of voids, for a triangular void, the coordination number is 3. Right? For a tetrahedral void, coordination number is 4. For an octahedral void, coordination number is 6. And lastly, for a cubic void, coordination number is 8. Alright. So here the coordination number of a metal crystallizing in HCP structure, this is hexagonal close packed, so it will be 12. That will be the correct answer in this case. Then these types of questions are also asked in JEE, where they ask questions based on the geometry of the unit cells, right? Read this question carefully. The radius of the largest sphere which fits properly at the center of the edge of a body centered cubic unit cell is. So I have taken up this question to explain how do you use the relations that we derive in solid state, right? So basically this is a body centered cubic unit cell, okay? And if you use logic properly, then these questions are really very easy. And if you will see, these questions have been asked frequently in JEE Main and Advanced, right? Okay, so in a body centered cubic unit cell, you know that there is one particle here, there is one particle here, there is one particle here, right? You can show like all the particles like that, right? Now read the question again. The radius of the largest sphere which fits properly at the center of this edge. So this is the edge and this is the center, right? So basically they are putting a particle here. What will be the radius of this particle? Okay, let us apply the logic here. Let us call this edge as A and B. Okay, radius of this larger particle, capital R, radius of this smaller particle is small r, which is the answer, right? So radius of the larger particle is capital R and the radius of the smaller particle is r. So you can see that edge length, right? Edge length is 2 of capital R plus 2 of small r, right? Very easy, no problem in this. So edge length is 2 of capital R plus 2 of small r. Edge length is A. So A is 2r plus 2 small r. What is your answer? What is your answer? The radius of the particle which fits at the edge center. So my answer here would be r is equal to A minus 2r divided by 2. I hope this much is understood. Now, in the next step, we will get our answer. Now tell me, you have to find out this radius, right? If I am able to express A in terms of R or R in terms of A, then I'll get my answer. And you know that that's very easy. In the beginning of this video, we show that the formula of the relation between the edge length and the radius of a body centered cubic unit cell is root 3 is equal to 4R, right? Remember? So root 3A is equal to 4, I'll take capital R. Is that clear, right? So I'll take it. This root 3A is equal to 4R. So because the answer has to be in terms of A, right? So I'll replace R. So I'll write root 3A by 4. Okay. So A minus 2 multiplied by root 3 by 4A divided by 2. This will be cancelled, right? So answer would be, right, the radius would be A 1 minus root 3 by 2 divided by 2. Okay, so radius would be A, then this would be 2 minus root 3 divided by 4. If you take root 3 as 1.73, then 2 minus 1.73 would be 0.27 divided by 4, so 0.06 something. That will be your correct answer. So 0.067 times the edge length of the unit cell. So you see, it's a simple application of geometry of the unit cell, right? Then now beginning with the questions of electrochemistry. In electrochemistry, there are some formulas on which you get questions repeatedly. For example, specific conductance, molar conductance, Colruy's law, in Nernst equation, relation between Gibbs energy and the EMF, right? Nernst equation itself, and then you have to remember the Faraday's laws of electrolysis, right? Look at this question. The resistance of 0.2 molar solution of an electrolyte is 50 ohm. Okay, and the specific conductance, which is kappa, of the solution is 1.4 Siemens meter inverse. The resistance of 0.5 molar solution of the same electrolyte is 280 ohm. The molar conductance of 0.5 molar solution of the electrolyte in the units of Siemens meter square and mole inverse. So let me just quickly brush up the formulas here. So first thing that you guys have to remember is this, right? G star, cell constant of a conductivity cell, is equal to the product of the resistance and the specific conductance of the solution that you have filled, right, in the conductivity cell. Now cell constant is length divided by area of cross section. So it is either in the units of centimeter inverse or meter inverse, right? Resistance, you know, it is measured as ohm, and kappa generally Siemens centimeter inverse or meter inverse. That depends upon the choice of units, right? Then we know that molar conductance is actually kappa divided by concentration, right? For any electrolyte, molar conductance is kappa divided by concentration. Now there is a mismatch of units here, right? Because concentration is expressed in mole per liter. Now you guys know that 1 liter is 10 raised to the power 3 centimeter cube or 10 raised to the power minus 3 meter cube. So you have to check out that first the molar conductance, does it need to be calculated in Siemens meter inverse or centimeter inverse, right? So if this kappa is in Siemens centimeter inverse, then you will multiply, I'll tell you, right? If this is in centimeter inverse, then you will multiply, right? Here you will get it Siemens centimeter square mole inverse, right? If this kappa is in Siemens meter inverse, then you'll have to divide. If this is in meter inverse, then you'll have to divide your concentration by 1000 if you want to obtain your molar conductance in Siemens meter square mole inverse. So this is a background. Quickly we have revised the formulas that we need for this question. Let us come back. Case 1. Resistance of 0.2 molar solution is 50 ohm. Let us apply this formula. G star is equal to resistance into kappa, right? Resistance is given to be 50 ohm multiplied by kappa. Specific conductance is 1.4 Siemens meter inverse. So 1.4 into 50 is 70, and ohm and this will cancel, it will be meter inverse, right? So cell constant has come out as 70 meter inverse. So now you remember, cell constant is a constant. It does not depend upon the nature and the concentration of the solution that you fill in it. In the second case, the resistance of the 0.5 molar concentration has changed. So resistance will change, kappa will change, molar conductivity will change. 0.5 molar solution of the same electrolyte is 280 ohm. Again apply this formula. G star is equal to resistance into kappa. This time G star is 70 meter inverse. Resistance is 280 ohm, right, multiplied by kappa. So you can check that kappa is 1 by 4, that is 0.25 Siemens meter inverse, right? So this is your kappa, 0.25 Siemens meter inverse. Finally, now it is the time to find out the molar conductance. Molar conductance is kappa by C and a factor of 1000, right, depending upon whether you use centimeter or meter in the units of kappa. So kappa is 0.25 Siemens meter inverse divided by concentration. Concentration is how much? 0.5, right? Concentration is how much? 0.5 multiplied by 1000. So now that will give your answer in Siemens meter square mole inverse as is expected, right? So this is 0.5 into 10 to the minus 3 or 5 into 10 raised to the power minus 4. That will be the correct answer. So a very decent question that explains and clarifies the concept of cell constant, specific conductance and molar conductance. Moving to the next question. This question is selected because it explains Kohlrausch law and an application of Kohlrausch law, right? So this is lambda infinitum or lambda naught m. For NaCl, HCl, this is a sodium salt of a weak acid, are 126.4, 425.9 and 100.5, right, respectively. If the conductivity of 0.001 molar is this, so this is a unit of kappa, so they are actually talking about a specific conductance or just conductivity, right? The degree of dissociation of the weak acid is something they have asked. So let me again tell you the formulas here. Please remember that degree of dissociation of a weak electrolyte at concentration C is the molar conductance at concentration C divided by lambda infinitum, right? Alpha is lambda m divided by lambda infinitum, molar conductance at concentration C divided by the limiting molar conductance, right? Now lambda m and lambda infinitum, what have they given us? They have given us nothing, right? So we have to calculate both. Now we know lambda m is, it's very easy to calculate, right? We can calculate by kappa by C. So let us check that. If the conductivity, this is given, right, and concentration is given, so lambda m we can calculate. So kappa is 5 into 10 raised to the power minus 5 Siemens centimeter inverse, right? So we have to multiply it by 1000 divided by the concentration, right? The concentration conductivity of 0.001, that is 10 raised to the power minus 3, right? So this is how much? 10 to the minus 2 and 50 Siemens centimeter square and mole inverse. So this is a lambda m, right? This is a molar conductance at this concentration. Next thing we need is limiting molar conductance. Now that's a very simple application of Kohlrausch law, and JEE Main asks even direct questions based on this application of Kohlrausch law. So Kohlrausch law is nothing. It just says that at infinite dilution, the distance between the ions of an electrolyte is so large that their interactions are practically negligible, right? The distance between the cation and anion of an electrolyte is so large at infinite dilution that we can ignore any interaction between them. In such a case, both cation and anion move independently of each other, and the total conductance of the electrolyte is algebraic sum of the ionic conductance of individual ions. So that's very clearly put form of Colrosh law. So now we have to calculate alpha for HA. So we'll have to calculate lambda m for HA, right? We have to calculate lambda infinitum of HA. As per Colrosh law, the limiting molar conductance of this electrolyte is just the ionic conductance of H plus and the ionic conductance of A minus. Right? Very simple. Ionic conductance of H plus, ionic conductance of A minus. Okay. Now, H plus is where? In HCl, whose value is 425.9. For clarification, let me write. So, I need H plus. So, I will take molar conductance of HCl, right? That will give me the conductance of H plus and Cl minus. Cl minus I will get rid of later. So, H plus, I need another A minus. A minus is in this. So, lambda infinitum NaA, right? So, that will give me the molar conductance of Na plus and A minus. I need A minus, I will get rid of Na plus. So, you see, I need H plus and A minus. I have to get rid of Cl minus and Na plus. So, I will subtract NaCl. Very simple, right? A simple mathematical problem. I'll subtract NaCl, I'll get overall the limiting molar conductance of HA. Let us substitute the values. HCl is 425.9 plus NaA is 100.5 minus NaCl, that is given to be 126.4. Right, all these values are in Siemens centimeter square mole inverse. Okay, so this is 25.9 plus 5, it is 26.4, right? So this will be 526.4 minus 126.4, 400 it will be. Now the answer is in front of you. Molar conductance is 50 and limiting molar conductance is 400. So alpha will be 50 divided by 400. So 0.125, that will be the correct answer. So this is the complete application of the Colrosh law, right? And an application of Colrosh law as well. Moving to the next question. This is a concept where you make mistakes because you're not focused, right? Otherwise, these questions are very easy, guys. And the concept is very basic and important to electrochemistry, and there are many questions in JEE based on this concept. Okay, so always remember that higher the reduction potential, higher will be the oxidizing strength, right? Oxidizing strength is directly proportional to the reduction potential. Remember this. Okay, or I also share this mnemonic with students. Many of you may know this already. So L means low potential, L means low potential, O means oxidation, O means oxidation, A means anode, N means negative. This is true for a galvanic cell, right? That in a galvanic cell, anode is negative. I hope you have figured that out by now. Anode is negative. What happens at anode? Oxidation. And what should be the condition? The potential should be low, right? You can reverse that. Low, opposite of low is high, opposite of oxidation is reduction, opposite of anode is cathode, opposite of negative is positive. That means cathode will be positive. At cathode, reduction happens, and that should have high potential. This means higher potential means reduction. Now, if a substance undergoes reduction, it acts as oxidizing agent, obviously, right? That is why I have written this relation. Oxidizing strength is directly proportional to reduction potential. That means, let me elaborate it a little so that it sits deep in your brain. Higher the reduction potential, greater the strength of oxidizing strength. That means greater the tendency for reduction. Or lower the reduction potential, lower the oxidizing strength, or higher the reducing strength. That means greater the tendency to undergo oxidation, right? Here, all of these are reduction potentials, you can see, SRPs. Which is the highest value? 2.05, obviously, 2.05, 1.09 and 1.4, right? So which is the highest value? 2.05. So this redox couple has the maximum tendency to act as the reduction couple, right? Now, of course, The strongest oxidizing agent means the one which has highest tendency to undergo reduction. So of course this will want to undergo reduction to give you this. So the correct answer is peroxide disulfate, right? So the correct answer will be this. The lowest potential is for bromine, right? You can see that this is the lowest value. Lowest value means it is the strongest reducing agent. It is the strongest reducing agent, right? Oxidizing is directly proportional to reduction. Reducing strength will be inversely proportional to reduction potential. So this is the minimum value. This will be the strongest reducing agent. That means it has the maximum tendency to undergo oxidation. So bromide ion will show maximum tendency to undergo oxidation to form bromine ion, and peroxide disulfate ion will show maximum tendency for reduction to form sulfate back. Together they will form a galvanic cell, right? So this is some additional concept which I have explained. This question again a very important application of Gibbs energy and the relation between Gibbs energy and EMF. So we know that Gibbs energy is minus NF E naught. If you're not talking about standard conditions, then delta G is simply minus NF E, right? Where N is the number of electrons in the equation, F is the Faraday constant. You guys know that, either 96487 or for simplicity 96500 coulomb per mole. E is the potential, whether half cell or galvanic cell. Now the question is, let us do it in a retro way. The value of a standard Gibbs energy change, that is what we have to calculate for the following half reaction. So one thing I know, the delta G naught will be minus number of electrons is 1, right? Number of electrons is 1, is that clear, right? Multiplied by the E value, multiplied by the E value, right? E naught value. The point is, I don't know E naught. Delta G is minus N F E. N is 1 number of electrons. F I will substitute, right? They have not specified, but we'll take, let's say 96500, right? Then E naught is the standard reduction potential, but that is not given. So using these two redox couples, we will find that. So please remember, whenever the redox couples of the reduction potentials of two redox couples are given, and you're supposed to find out the reduction potential of the third redox couple, never add or directly subtract them, right? Because that is done via the Gibbs energy, right? Okay, right? So let us do this first. Fe3 plus slash Fe. So Fe3 plus takes up 3 electron, it produces iron. The Gibbs energy of this reaction would be minus, right? Minus 3 electrons are there, Faraday constant multiplied by the potential, which is minus 0.036. So this will be plus 0.108 Faraday, right? 0.108 Faraday. Then for the second redox couple, Fe2 plus 2 electrons, it gives Fe, right? Fe2 plus ferrous ion accepts 2 electron. In this case, let us say the Gibbs energy would be minus number of electrons 2 multiplied by Faraday constant multiplied by the potential, which is minus 0.44, right? So this will be minus plus 0.88 F. Now using these two equations, you have to construct this equation. Ferric I need on the reactant side. Yes, it is there on the reactant side. But ferrous I need on the product side. So I will reverse this equation. Ferrous will be formed from iron. Because you have reversed the equation, Gibbs energy will also be changed, right? Gibbs energy sign will also become, again it will become negative minus 0.88 Faraday. Now please note that if you add this one and this one, so iron will cancel and 3 electrons and 2 electrons, so this 2 electrons will cancel. Overall equation will be this one, Fe3 plus electron gives Fe2 plus. So because this equation has been formed by the addition of these equations, the Gibbs energy, which is minus Fe naught, will also be the sum of these Gibbs energies, right? Which means that this will be 0.108 Faraday plus minus 0.88 Faraday, right? So the Gibbs energy will be the sum of these Gibbs energies. F we can cancel, right? And minus sign when we will take on the other side, so it will be 0.88 minus 0.108. So this will be 0.772, right? So this will be 0.772 volt. So that is what we have done so far. Okay. Finally, you have to find out the Gibbs energy. So we know that delta G naught is minus 1 into 96500, right? Multiplied by what is the E naught? 0.772. Answer has to be in kilojoules. So please divide it by 1000. So that will be your answer. I think you could do the calculation. You guys are smart. So delta G naught will be minus 96500, right, into 0.772 divided by 1000, right? So that will be your Gibbs energy in kilojoule per mole. Then this question, a dilute solution of sodium sulfate is electrolyzed using platinum electrodes, the products at the anode and cathode. In such question, you can obviously see that this question is based on the products of electrolysis. All right. So what we will do in this question, first you notice that electrode is inert, right? Platinum is an inert electrode. It only provides surface for electrode reactions and pathway for the conduction of electrons. Otherwise, it does not participate in the reaction. Okay. We are using an aqueous solution of sodium sulfate. So what are the ions? The electrolyte is sodium sulfate. So Na plus and SO4 2 minus, Na plus and SO4 2 minus, that is the electrolyte, and aqueous means water is itself is a weak electrolyte. So it will ionize to give you H plus and OH minus ions, right? Now you have to figure out which ions will go to anode and which ions will go to cathode. Of course, this will undergo reduction, this will undergo reduction. So these two ions will migrate towards cathode. Now which of them will have higher tendency for reduction? Now there is a reduction tendency for cations and oxidation tendency for anions. Please remember these two series. Okay. So out of Na plus and H plus will have higher tendency to undergo reduction. So we know that when H plus ion will undergo reduction, it will form hydrogen gas, right? It will form hydrogen gas. Under normal conditions, right, what will happen? This sulfate ion and hydroxide ion, these both will migrate towards anode, right? And hydroxide will have higher tendency for oxidation. So when hydroxide ion undergoes oxidation, oxygen gas is produced, right? How do we actually exactly write it? See, water, you split it into 2H plus and O2 minus, right? 2H plus are there. They will try to decrease the pH of the solution. O2 minus, you remove 2 electron, right? That leaves you with oxygen radical. And 2 of these oxygen radical will combine to form oxygen gas, right? So that is how you write the balanced equation for the oxidation of water. So you can see that at anode, oxygen gas is formed, at cathode, hydrogen gas is formed. So O2H2. So that is the correct answer. Anode, oxygen, and cathode, hydrogen gas. That is the correct answer. Now let us discuss some important questions of chemical kinetics. This is one type which is asked very frequently in JEE, based on the order of reaction. A reaction is second order with respect to the reactant X and first order with respect to the reactant Y. By what factor the reaction rate would change if the concentration of both the reactants are doubled? So in JEE, you don't have to do it in a very systematic way. You can just see what are the relation, right? Okay, so because the reaction depends upon supposedly the reaction depends upon reactant X and Y. So I can write that the rate of reaction is rate constant, concentration of A raised to the power X, which is called the order of reaction with respect to A, and B, is it A or B? Is it X and Y, right? So this is rate is equal to K. The reaction is second order with respect to the reactant X. Second order with respect to the reactant X, that means the power of the concentration term of X is 2. And first order with respect to reactant Y, the concentration of Y, first order means just 1, we will not write anything. Now if we double the concentration of both reactant, by what factor the reaction rate would change if the concentration of both reactants are doubled? So if you double the concentration of X, so you can see that if you double the X, it becomes 2X, X leaves behind 2 raised to the power 2. If you double the concentration of Y, so 2 raised to the power 1. So overall there is a change of a factor of 8 in the rate of the reaction, right? So the reaction rate would change by a factor of 8. So these are a very common question. Attempt them very carefully. They are simple, right? But if you lose your focus and make some silly mistake, then you'll lose your marks. This is another type of question, and I have chosen this question because I'll show you how to simply solve it, right? Consider the kinetic data given below for the reaction A, B, C product. So I will assume that the rate law is K, rate constant, A raised to the power X, let's say, B raised to the power Y, and C raised to the power Z, right? Rate is equal to K, A raised to the power X, B raised to the power Y, and C raised to the power Z. Now, what do we do in such question is we keep the concentration of only one reactant varying and others fixed, okay? For example, if you see experiment number 1 and 2, the concentration of A is fixed, the concentration of C is fixed, right? Am I correct? So A is fixed and C is fixed, B is doubled, so you can see there is no change in the rate of the reaction, right? There is no change in the rate of the reaction. As the concentration is doubled, there is no change in the rate of the reaction. That means this term is not there. That means Y is equal to 0. Y is equal to 0, B raised to the power 0 is 1. So this term is not there. Okay. So we have found out the order with respect to B is 0. Now let us check some other data. B has been ruled out. Okay. Now let us check with respect to A. Okay. With respect to A, so we'll have to change the other two. We'll have to keep the other two fixed, right? So what about 1 and 4? What about 1 and 4? The concentration of C is fixed, 0.1, 0.1. The concentration of B is fixed, 0.1, 0.1. That anyway does not matter because the order with respect to B is 0. So the concentration of A, as it is raised from 0.2 to 0.3, that is, it is increased by a factor of 1.5, right? I hope this is clear. From 0.2 to 0.3, that is, it is increased by a factor of 1.5. You can see the rate of reaction also becomes 1.5 times, right? Very simple. 0.3 by 0.2, 0.3 by 0.2, it is 1.5. Similarly, 9 by 6, that is also 1.5. Okay, that is also 9 by 6, that is also 1.5. So when you change the concentration by 1.5, the rate of reaction also changes by 1.5. So the power must be 1, right? Okay, the power must be 1. So A, when you increase it by 1.5, rate of reaction also becomes 1.5. So X is 1. X is 1. Now let us calculate C, keeping A and B fixed. All right, keeping A and B fixed. So analyze the data and find out what is the order of reaction with respect to C, that is Z. All right. So I can see that I can take 2 and 3 because A is fixed, B does not matter. As the concentration is doubled, right, from 0.1 to 0.2, the concentration, the rate of reaction also doubles, right? This can be written as 12 into 10 raised to the power minus 5. So when the concentration of C is doubled, the rate of reaction also doubled. So double, that means they are proportional. The order is 1, right? So Z is also 1. So the rate of reaction would be K, the concentration of A, and the concentration of C. All right, rate is equal to K, concentration of A and C. But the answer is not this. They just this is like the answer in those questions where they just ask the rate law. Those kind of questions are commonly asked in JEE Main. But here they have asked what is the rate of reaction under these conditions. So yes, we can calculate the rate of reaction, but we need the rate constant for that. We need the rate constant for that. Let us use any of the 4 sets and first calculate what is rate constant. I'll use the first one. So rate of reaction is 6 into 10 raised to the power minus 5. right? 6 into 10 raised to the power minus 5. The concentration of A is 0.2 and the concentration of C is 0.1, right? So K would be 6 into 10 raised to the power minus 5 divided by 2 into 10 raised to the power minus 2. Is that clear? Right? So rate constant would be, of course, 3 into 10 raised to the power minus 3. So rate constant has come out to be 3 into 10 raised to the power minus 3. Now you can substitute that back into this and the given concentration. What I am trying to say is the rate of the reaction for this is this, you have to calculate. So rate would be rate constant, which is 3 into 10 raised to the power minus 3 multiplied by the concentration of A, which is given to be 0.15, multiplied by the concentration of C, which is also 0.15, right? So this will be, if I adjust that, 15 into 15, 225, 225 into 3, this will be 675, 675 into 10 raised to the power 2437, right? Or they have expressed in the form of minus 5. So this will be 6.75 into 10 raised to the power minus 5. So Y will be 6.75. Look at the whole question. We have explained a lot of concepts in this question. So 6.75 into 10 raised to the power minus 5. That is the correct answer. Okay. Moving to the next question. This question is selected because it explains the equations for zero order, reactions. The reaction 2x gives B is a zero order reaction if the initial concentration of X is 0.2 molar, half-life is 6 hours. Let us see for zero order reaction, what are the equations? For zero order reactions, please remember the rate constant is initial concentration minus concentration at time t divided by the time interval, right? For rate constant is A naught, that is initial concentration, minus concentration at time t or final concentration divided by the time interval. Is that clear, right? Half-life for a zero order reaction is initial concentration divided by 2 times the rate constant, because you see for half-life AT will be A naught by 2, so that will be A naught by 2K. So these are the expressions that you have to use in this question. Initial concentration is 0.2, so half-life is 6 hours, right? Now we know half-life is initial concentration divided by twice the rate constant, so I'll calculate rate constant. Rate constant will be initial concentration, which is 0.2 divided by 2 multiplied by half-life, which is 6 hours, right? So this will be concentration molar and hour inverse. I'll not solve this, I'll just leave it by this 0.6, okay? Then what will be the time required to reach the final concentration of 0.2? Now we will use this formula, okay? So time will be initial concentration, which in the second case is given to be 0.5 minus final concentration of 0.2, and you see divided by the rate constant. So this will be 0.1 divided by 6, this is 0.3 divided by 0.1 multiplied by 6, so time will be 18 hours. That will be the correct answer, right? So these are the two important expressions for zero order reaction, and that is how you can get question based on these equations. Moving to the next question, this question is selected because this is the most common type of question asked from first order, and many students do it the lengthy way. So I'll show you a short way of doing it. Whenever initial concentration, whenever they talk in fraction, take the initial concentration as 1. Whenever they talk about percentage, take the initial concentration as 100, right? That is one simple logic that you will find helpful. Now we know that for a first order reaction, for first order reactions, the rate constant is 1 upon time natural log initial concentration divided by concentration at time t, right? And you know that if you convert it to log, then you will put it here 2.3, right? 2.303. Then This is also sometimes used, that concentration at time t is initial concentration e raised to the power minus kT. This is also very commonly used, first order integrated rate equation. Then the degree of dissociation of a first order reaction is 1 minus e raised to the power minus kT. It is also asked directly, right? Because a first order reaction never completes, we can calculate the degree of dissociation, that will be 1 minus e raised to the power minus rate constant into the time at which you are calculating the alpha. Okay, so this question can be solved using this, right, expression. Let us discuss it. So what we are going to do here is that 75% is completed in 90 minutes. So I'll just rearrange my equation. T is 1 upon K, right, or more of 2.303 by K, which will be cancelled anyway. So 2.303 divided by K log, right, initial concentration divided by concentration at time t. Okay, let us use this. Initially, for 75% completion, time is 90 minutes. Okay, so 90-minute time is consumed if the concentration of the reactant is 75% done, right? 75% of the reaction is completed. That means initial 100, 75% is completed, so remaining will be 25. Okay, right? So log 100 by 75% is complete, 25% is left, so that is 25. We have to calculate how much time will the reaction take for 60% completion. 60% completion of the same reaction would be in how much time? So that let us call it T. It will be again 2.303 divided by rate constant log 100. You are completing 60%, so you are leaving 40%. 60% is completed, 40% is left. Now let us divide these two. Here you will realize that actually makes your calculation very easy, okay? Because now you can cancel it. See, now you can cancel it. 2.303 by K, now you can cancel it, okay? What about the other numbers? Let us see them also, because let's face it, in some numericals of chemistry, you have to be good at solving logarithms, right? So this is 25 by 100 by 25, that is log 4. And this I will leave just at that, or 10 by 4 is 2.5, because they have given the value of 2.5. So that is 2.5. Okay. So now let us solve it. So it is 90 by T. Okay, see it clearly, right? You can see that it is short. 90 by T, this is cancelled. Log 4 is 2 log 2. Log 4 is 2 log 2, and log 2 is 0.3 divided by, this is cancelled, log 100 by 40, which is just 2.5, and log 2.5 is 0.4. All right. So the time for 60% completion would be 90 into 0.4 divided by 2 into 0.3. All right. Is that clear? So that is 60 minutes, right? So that will be 60 minutes. Next question. Two reactions R1 and R2 have identical pre-exponential factors, which is capital A. The activation energy of R1 exceeds that of R2 by 10 kJ per mole. If K1 and K2 are rate constants, what is the value of natural log K2 by K1 at 300? Let us just quickly revise Arrhenius equation, because you know this is very important equation. So Arrhenius equation says that K is equal to A multiplied by this factor, right, which we call Arrhenius. This is A is Arrhenius factor, pre-exponential factor, or frequency factor, because it gives you the number of collisions irrespective of their energy, right? EA is activation energy, minimum extra amount of energy required to be possessed by the reactant molecules for a successful collision. And this exponential factor is the probability of success, right? What are the chances that a given collision will be successful? Okay. Now if you take the logarithm, natural log, then ln K is equal to ln A minus, or let's say plus, ln E raised to the power. Now you guys know that log A raised to the power B is B log A. So this can be written as ln A plus minus EA by RT of ln E. So just like log 10 is 1, ln E is 1 because the base of this ln is E. So I can write that ln K is ln A minus EA divided by RT. Alright. Now if you are considering rate constant at two different temperatures, based on that equation again there are many questions in JEE. So you guys know that you can rewrite this equation as log K2 by K1 is activation energy 2.303 R 1 upon T1 minus 1 upon T2, right? Remember to substitute the temperatures in Kelvin. At T1 rate constant is K1, at T2 rate constant is K2. Then they ask various types of questions based upon them, right? But here we have to use this, right? Let's go back to the question. They have identical pre-exponential factors, which means I can write ln K1 is ln A, right, minus activation energy EA1 divided by R. Temperature is how much? 300. And for second case I can write ln K2 is ln A, right, minus the activation energy EA2 divided by R into 300. Now always when you are solving numericals, be smart, right? Don't do calculations or the steps unnecessarily. Your focus should be to do the steps of the numerical in a direction that gives you the answer in minimum number of steps, right? What I'm trying to say here is that you have to find out ln K2 by K1. So that you know is ln K2 minus ln K1, right? Because log A minus log B is log A by B. So what I will do, I will just subtract this out of this. So ln K2 minus ln K1, right? ln K2 minus ln K1. So this will be, this I am doing to just show you guys, right? Otherwise you can do directly ln A minus EA2 R into 300 minus this. So this will be minus ln A and minus minus plus EA1 R into 300. This will cancel. ln K2 minus ln K1, that will be ln K2 by K1. That is going to be our answer. So that is going to be EA2 by R into 300, EA1 by R into 300, right? So EA1 by R into 300 minus EA2 by R, right? So this is 1 by 300. The value of R is 8.314 and inside it will be EA1 minus EA2, and you have seen that the activation energy of first reaction exceeds that of by 10 kilojoule, that is 10,000 joule. So your answer precisely would be 10,000 divided by 300 multiplied by 8.314. Now you can check that 8.314 into 3 is approximately 25, right? Not exactly, but approximately 25. 100 by 25 is 4. So the correct answer in this question is going to be 4. So that will be, that is how you solve the questions based on Arrhenius equation. Alright. So that's all in this session of the revision of these 3 chapters. In the next video, I will be coming up with some important questions from some very important chapters of organic chemistry. So please do subscribe to this YouTube channel so that you know when there is a video and when you have to watch it and add an edge to your preparation. So I'll be back tomorrow with another video on organic chemistry. Till then, keep studying. Take care. Bye-bye.